Hey, so today I'm going to be doing a walkthrough of the machine Optimum from Hack the Box. This one's a pretty simple machine overall, but it was a little tricky at one point because I didn't know something about 64 versus 32-bit processes and the ways that they will get executed, especially when you're running some of these exploit scripts. So I'll make sure to explain that part when I get to it. It was actually really interesting and useful to learn, so I enjoyed doing this box. So let's get started. First things first, as always, I would want to run my Nmap scan, and again, I've already done that just to save some time, so let's take a look at the outputs of the scan. We can see that there's really only one service open, and it's port 80. It seems to be running some different file server that we haven't encountered before. So I'm going to pull up the actual web server real quick and take a look at it. Okay, we seem to have some way to archive, maybe select and download files, and it's showing that there's no files in this folder. But we also see that we have HTTP file server version 2.3. And since this is possibly a custom file server, or it's not too popular, it would be a good idea to go ahead and take a look at it. So it's Rigetto HFS. You can use this file server to send and receive files. It's different from classic file sharing because it uses web tech to be compatible with today's internet. It's interesting when we encounter things like this. It's usually a good idea to hit up Searchploit to see if there's any known vulnerabilities in these servers and in whatever application you might be looking at. So HTTP file server, and we have a few different things. Okay, we have Rigetto HTTP file server 1.5, 2.x. We're running 2.3, so we can see over here that there's remote command execution available for it, which means that we're definitely going to be wanting to take a look at this. So let's locate this file and copy this in. We'll call it exploit.py. So let's take a look at the exploit and what it does. I'm gonna increase my terminal size here. Yeah, that should be sufficient. So here's the same description. Usage: Python exploit.py, target IP address and target port number. You need to be using a web server hosting netcat. Attacker's IP at 80 with netcat.exe. So let's see what it actually is doing. We are using VBS, sending a request to, let's see, HTTP. I think, yeah, IP address is our local IP address, and so it's going to be looking for netcat.exe on our local web server, and then it's going to be using that with some HTTP responses as well to execute netcat is what it seems like. So yeah, it'll be doing that, and it'll be trying to use the netcat that it grabs off of our web server to open up a reverse shell to whatever our local port and our same IP address is going to be. So since local port's only referenced once, and because this HTTP request is grabbing netcat.exe without any port number, we're going to have to run our web server on port 80. So that seems pretty straightforward. Let's take a look and see what our IP address is here. 10.10.14.16. So let's customize that real quick. 10.10.14.16. And now we are going to want to use whatever port we want. I personally just like port 9000. I don't really know why, but you'll definitely notice that through the course of my videos. So we need to first copy over netcat.exe, which should be in user share Windows resources, binaries, and netcat. Yeah, netcat.exe. So let's copy that over to our current directory. And now I'm gonna split panes real quick just so I can, just to make this a little cleaner. Python 3-m http.server, and we'll run it on port 80. So now we have our simple web server up, which the script can use to grab our netcat file. So let's open up our reverse shell for when this exploit goes through Python exploit.py, and I think it's the target IP, which should be 10.10.10.8, and then the target port, which should just be port 80. Let's run it. It got netcat.exe, but it did say we might need to run it a few times. And yep, right off the bat, we already have a reverse shell. And we're Costas, so can we print out this user.text? We can. Okay, that was extremely straightforward to be able to get the user file. So now we're going to need to look into some privilege escalation and need to figure out how we're going to manage to get ourselves to root. So first good check is going to be to run system info, and I like to use the Windows exploit suggester script, which has a database of some exploits against patch versions, and that's a pretty quick and easy way to get some suggestions. An alternative would be to use Sherlock, but then we would need to execute PowerShell, which we could do, but I'm going to just use this first. So let's see, I'll call this Optimum. Actually, I'll call it system info. Optimum. So let's just go up and grab all of the output. I'm also going to try, actually, I don't think this will matter too much with all of the extra lines, with these line breaks in there. If it doesn't seem to work, then I will go back and clean all of that up, but I've never encountered an error from it so far. Oh, it's not pasting. Okay, there we go. So now we have 10. Ooh, I just missed 1 or 2. Network card. Okay, so we have to get these last few lines in, and then we can run our script. So the script for me is located under user share, Windows resources, then exploit suggester, and the Python file. So system info file we've just created is in our current directory, and the database is also going to be under the same directory as the script is, and for me, this is when I generated it, so that's going to be the name. Now let's run it and see what we can find that's interesting. For now, we don't need, oh, oops. We don't, that's not what I wanted to do. There, okay, there we go. So let's take a look and see what this output. Also, before we do that, let's also take a look at what this patch version was, so we can tell what date this occurred on, just to be able to look at our vulnerabilities and cross-reference when the date should be. So November 2014 is the most recent patch applied, so MS 15 to 16 is likely going to be exploits that are viable. So we have security update for Windows kernel mode drivers. We have that same vulnerability here again, and we have quite a few different options, it seems. One thing we're going to have to go and check again is to see, oh, that's also not what I wanted to do. There we go. We're going to want to see what architecture this system's running. So it's a x64 based PC. meaning it should be 64-bit. And is there anything else interesting? One processor installed. It's AMD. We can also go ahead and look up vulnerabilities for this particular version. So Windows build vulnerabilities, and so there's some different links over here. I've clicked a lot, but we don't want to really look at any of the walkthrough links. There's a local privilege escalation with PowerShell MS1632. So how does this one work? In order for the condition to succeed, the machine must have 2+ CPU cores. So 1 processor is installed, 2 authentic AMD. We can look up this model and check to see if it has 2 or more cores. Knowing AMD, I would not be surprised if it did. I see 2 threads. I'll have my proxy on, I didn't even notice that. So while that opens up, oh, there it is already. Let's just look up model 23. It shows up a few times, and it shows up 2000 megahertz. So it could be these processors, which I'm assuming this is the core count, all have 4 cores. No, 4 threads. So yeah, it should be 2 cores, which is exactly what we need for this exploit to potentially work. Let's keep looking. Let me make sure that I get the number of this. MS1632. Was that picked up by our script? It was. Okay, so there's one very potential route to exploit this. We could go ahead and try this first, I guess, since when we did our quick Google search on the version, this was one of the first exploits that actually showed up. So, we don't necessarily need this server open anymore. I will go ahead and clean this up again. So MS1632, we should have that somewhere in user share Windows exploits. MS1632, yep, that is there. / MS1632. And there's an executable which I've saved and a PowerShell script. So if we're going to be using the PowerShell script, we're going to want to be able to maybe run this through we're going to need a way to upload this file or have the Windows machine access our script. Same thing we would need to do if it was an executable. So there's a few different options. Given that this is PowerShell, we might want to try and locate where PowerShell is on this system. So this is, since it's under the system32 file, this is very likely going to be a 32-bit version. Or actually, I think syswow64 is where the 32-bit versions are, which is kind of ironic, but I think that's just how Windows has implemented it. We could go and run a web server from this directory. MS1632 PowerShell. We'll just copy it over to where we are right now. And now what we can do is PowerShell. Oh wait, we have to start our server. Python http.server. Oops. Port 80. And now we can use PowerShell exec. Actually, just to be safe, I'm going to go and launch the specific or PowerShell from the location that the system showed us it's at. So exec bypass. This is so we can bypass any set execution policies that might be set for our user for any other users on the system, which PowerShell will automatically be detecting. So bypass dash command. Now we're gonna create a new object, system.net.webclient.download file. We could use download string or download file, but in the off chance that something goes wrong, since this isn't a we're not too worried about the file showing up on the system for any logs or anything, but download file would actually write to the disk, whereas download string would only write to RAM and be executing whatever we get from our request in the RAM directly, so it's less traceable. So download file, oh oops. Okay, good thing that didn't crash or do anything. I accidentally hit enter there. So HTTP, our IP was 10, 10, 14, 16, I think, slash, going to just run an ls real quick. So ms1632.ps1, ms1632.ps1. And now we have to have an out file into what we have to have an out file for this. So let's do just exploit.ps1. How unoriginal. I forgot my quotation. Exploit.ps1. And now it should download. Missing a parameter. So what were we missing? Unexpected token in expression. This comma. So I'm gonna try something random here and see if just typing PowerShell. I assume this will give us the same error. Yep, this does give us the same error. So I'll type it again just to make sure. Object system dot net dot web client dot download file. Let's try it with single quotes. 10, 10, 14, 16 slash ms1632.ps1 and out. Will this error again? Now it's just hanging. So net object is not. Oh, okay. That time it's because I didn't type new object. And this time it actually grabbed the file. So it can be kind of weird if you use single quotes versus double quotes. I don't actually know what the reason for that is, but using single quotes worked. My guess is that it's going to be reading this in as a string when you pass the dash command flag, so it might just automatically be adding double quotes before anything we type in, which is why having double quotes inside the string messed it up. We could actually test that. In fact, I will actually test that just to see if I was to do this. How would I go about testing that? There was only one other difference, in which case I had a semicolon at the end of it, and that still worked. So it seems like it would be based on the double quotes. Download file. out.ps1. And yeah, we get the error. So it's only occurring when there's those double quotes. I'm going to look into that a little more, but for now, it's okay. So here we have out.ps1, and we can run PowerShell exec bypass dash file out.ps1 and see what happens. So we have an operating system count, core count 2, and it fails to capture the thread handles. So that's kind of odd given that we know this exploit should be working on this particular version of Windows and this installation. So this is where I had learned about the 64-bit versus 32-bit execution of different programs. So the exploit script that we actually used had, let's take a look at it. It was running using netcat.exe to run command.exe by default. So because something in this process chain is going to be a 32-bit process, it might be this script.vbs. It really could be anything. I haven't looked into it too much, but I realized that because something in here was a 32-bit process, command.exe could only also be executed as a 32-bit process, whereas this script has it has only been tested on 64-bit version of the specific operating system that we are going to be testing it on. So it might actually fail. But what we could do is here, we can exit out of our reverse shell and we can modify our script. I'll need Burp Suite open really quickly. New window, just to change our encoding. Okay, here we go. So if you go into Windows sys native and run command.exe, we're going to be getting the 64-bit version of command.exe just because of how Windows structures their system. If this file is present, I think it's a virtual directory that just has links to all of the 64-bit executables, and this folder is not it doesn't exist on a 32-bit version of Windows. So what we can do is we can take, really all we need is to encode as base 60, oh no, not base 64, as URL. So we look for the command.exe and append that. So now it'll be launching it from C:\\, Windows sys native, and in theory this should be executing the 64-bit version of command.exe. So Python exploit.py 10.10.10.8 port 80, and now if we are to run PowerShell -exec bypass out.ps1, oh oops, I forgot the file flag, out.ps1, notice that we get a completely different output, and that's because our script was meant to be running on a 64-bit version of this Windows, or the specific Windows version, and it we were trying to use a 32-bit version, which wasn't creating the threads as it was supposed to be. So the thing about this exploit is it's creating a pop-up shell which is in system rather than a reverse shell. So we could do two different things from here. One, we could try to modify the script and change the way that it's running command.exe. We could try to create a reverse shell using PowerShell, and then we would be able to get a system shell back through the reverse shell. As you can see, we're still close to this. We could also try to move to a different attack vector, because there were a lot of different exploits which are viable according to this. So instead of going and modifying our script, which we definitely can do, we can try out another exploit which might actually work. So MS16135 is denial of service. We don't want that. MS1698 is an integer overflow. We can take a look at this one. So just skim through it to see if it gives us any useful info. Here's a GitHub repository of this. So this seems to be able to properly prevesc us if the target's vulnerable to it. So we can take a look and see if we have this on our system anywhere. MS16098. If we do, it would be under user share, Windows exploits. Let's see if this exists. Okay, yep, we have this in here, so we can copy that over to our current directory again, and now this should be in here for us to download with PowerShell, and it is PowerShell.exec bypass command new object system.net.web client. Notice how I'm using this same exact command really often. It's something that's definitely worth remembering because it's really useful to download files using PowerShell or run some scripts that you might have elsewhere if you don't have very many options to download files. PowerShell seems to be installed on almost all of the newer Windows machines that I encounter, so it's always a good backup. Download file. Oh, oops. Let's call this exploit.exe. You can see over here it grabbed it, so let's validate that it's here. And it is. We can run this now. And we're NT authority system. So we can go into our root users, administrator, desktop, and now we can get the root flag. So as you can see, the box wasn't too difficult, but if you didn't know about, or if you didn't realize that this exploit would only be launching a 32-bit command shell, it could be a lot more frustrating, and you would have to go and try out a few different privilege escalations. Although, yeah, you would have realized that this specific vulnerability would be able to get you system access even using that 32-bit command shell though. But overall, this was a fun box, and I definitely learned something cool and useful from it, so Enjoy.